When the doors opened, there were hardly enough exhibits to fill the floor, but a lot of them were improvised from ordinary objects like old TV sets and speaker magnets, etc. You'll see some of those.
We're in the very beginning stages here of setting up an permanent exploratorium of science and technology and human perception, in which people will be able to understand natural phenomena and technology through working demonstrations by themselves. And the whole purpose of this place is to integrate different natural phenomena and make them understandable and not as fragmented as they are for the public. And natural phenomena include the things that are made by man, because that's a natural phenomena as well. This is a very beautiful example of an oscillation pattern displayed on an oscilloscope. Again, looks like a television set. This is an electric analog. We also have a mechanical analog of the same thing, a pendulum which swings, and we're going to mount eventually a very large pendulum which does the same kind of thing on the floor of the palace. Television set in which one can deflect the electrons with a magnet and make quite beautiful patterns. Someday, I suppose, there will be television art in the home. But this is also connected with the focusing properties of electrons. And similarly, we have a television set which reacts to the different frequencies with those microphones. Oh, it's a color television set and produces very beautiful, complex patterns. There are a great many other phenomena in nature that are even harder to portray than this, but perhaps we'll learn how.
Don't adjust your set. These are some snowy images from Color Day in 1977. The last of the 60s style. Some of the exhibits here are related to Frank's early work, such as this cloud chamber here, which is used to detect cosmic rays. Inside this chamber, you can see light streaks going through alcohol vapor, and these are the cosmic particles moving through and leaving a little ionization in their path. Before particle accelerators were widely available, Frank was sending cloud chambers up in balloons. Here we see him and two co-workers preparing a chamber to go aloft. He described some of this work for us.
The very special thing about science is that one isolates the business of finding out about something from the doing of it. And that, of course, isn't the only way in which new discoveries are made, but I think it's the way that's really made science flourish. And the experience that Pief mentioned with that we had with cosmic rays. We had General Mills was making balloons that would go to 100,000 feet, and we made a cloud chamber that fitted on it because we thought this would be a good way to do nuclear physics before the big accelerators were born in the late 40s. And but the first thing we found was these particles that were other elements, even as heavy as iron. So we were completely distracted from our interest in nuclear physics and followed this other path. And that you can't do if you're trying to do directed research.
This is the wave machine. It shows a transverse wave. Down the center here is a spring steel wire to which are soldered horizontal bars. These little collars should be adjusted so that it stays horizontal all the way down. The last rod has two dash pots on it, which we'll look at further, which dissipate the energy of the pulse in friction. So if I raise this up, it goes along and then very little comes back. It comes back along the top. Hardly any comes back. On the other hand, if I grab the last rod there with the magnet, which also turns on the light at the other end, and send a pulse down, let's look at it down again. Now that rod is held tight, and a fairly big pulse comes all the way back. But now I'm going to run it, not quite at the top speed, and watch what happens. Let's hear, because the waves are moving faster, the wavelength is longer. It goes further in one cycle than it does over here. But if you'll notice, each of these waves is running, moves along. If I look at any one place here, the wave goes right through that place. So that if I could follow that, if I take a crest and move along, it's like following a crest all the way along to the end there. They're running waves, like water waves, because nothing's being reflected to speak of at the far end. But if I grab the last bar by turning on a magnet, which also turns on the light at the other end, then all of a sudden the crests stay in the same place. If I look here now, the crests don't move, and that point there, where there's no crest, hardly any motion, it moves it doesn't move up and down at all. Adjustments on this end are quite critical. These can be loosened and slide in and out, and they have to be positioned in two ways. One, they have to be equal, so that if that's there, they balance, and this is horizontal. If this is too heavy or too far out compared to that, it'll go downhill that way. So one has to do that. In other words, you always have to move both of them. But where should they go sideways? One can only tell that by experiment, by inducing a pulse at the other end and then watching how much wave is reflected. I look down this now, I see little irregularities that should be fixed by adjusting the wires and by adjusting these little clips here that you can see from the top camera. These are the holders of the paddles, and they can be moved in and out. Let me show that with the camera that's looking down on the top here. If I loosen this screw here, I can take this clear out of there, maybe. Or maybe I have to unscrew it. I have to unscrew it here too, I guess. I can just turn this around. See, I can slide these in and out. The further out they are, the more effect they have. And if the damping is too great, then it doesn't work as well, and there's more reflected wave than if the damping is just right. So by moving those in and out and trying it with the pulse, and I did that just before starting, I have about the minimum. But these things here move in and out just as this one does. Now let's look in here from the end if we can. First I want to have people look at this paddle. It's perforated material and it's double. And the object of these is to get as much friction as possible with moving as little oil as possible. If they were plates, they'd have to move the oil out of the way to move up and down. Here the oil can go up and down through the hole and lose energy through turbulence. Because in order for this to be an energy absorber, one needs friction. And if every time you move the oil very much, the oil has inertia, it acts like part of the system here, and it's just part of the inertia and produces a wave of a different frequency. So these plates are double with a spacer between them, and they screw into these little pieces here,